So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the key word for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it. Okay, so welcome back. We are on lesson 3 of our unit 2, proportional relationships. Our aim for today is going to be how do we define and identify proportional relationships by using tables, graphs, and equations. So let's just review what a proportional relationship is. So a proportional relationship is a relationship between two variables where their ratios are equivalent. All right, and the constant of proportionality is the ratio between two directly proportional quantities. It's basically the unit rate. We're going to refer to it as the K value and also slope, as well as your constant of proportionality. So you want to become familiar with all of those terms. Okay, so let's go to how we can test proportionality. We covered this in the last lesson. So there's 3 steps. You can cross multiply and test the cross products. They would need to be equal. Another way you can do this to test proportionality is to simplify fractions. If they are simplified to be the same value, so they're equal, they have a proportional relationship. And the third way is find the unit rate. And the unit rate also needs to be so find the unit rate, and the unit rate also needs to be equal. For both fractions. Okay, so the equation for a proportional relationship is in this form. It's in y equals kx. The k stands for your unit rate, or your COP, which is your constant proportionality. Another equation that you can use, and in 8th grade you'll be using, is y equals mx plus b. But in a proportional relationship, it really is going to be y equals mx plus 0. So really it's just y equals mx. Your m, that is going to be your unit rate slash the constant of proportionality. And then your y and your x are just the coordinate points, or the different independent or dependent variables that you're going to use in the actual problem. So let's do some practice where we can use tables to identify your proportional relationship. So here we have In the first question, Danielle earns money babysitting. Based on the table, is the relationship between the amount Danielle earns and the number of hours a proportional relationship? If so, you want to write an equation for the relationship. Okay. So I know that money is always Y. Time is always X. So what I'm going to do is I know K is found out by Y divided by X. I'm going to say 12 divided by 1, 24 divided by 2, 36 divided by 3, 48 divided by 4, and 60 divided by 5. Basically, I'm finding my unit rate for each one. If I simplify, I'm going to get 12, 12, 12, 12, and 12. So my constant or proportionality, or my K value, is 12. So there is a proportional relationship. There is a constant of proportionality, and it is 12. And then if they want to have us write out our equation, we're following y equals mx or kx. All we have to do is just substitute in our unit rate. So we have y equals 12x. And that's going to be our equation. For number 2. So number 2 is showing a table with a height a tree has grown over time. Based on the table is the relationship between the number of years and the height in inches, a proportional relationship, and if it is, we're going to write out an equation. So we want to say number of years, again, years is time is going to be x, height is going to be y, so we want to do y divided by x, 18 divided by 1, 54 divided by 2, 90 divided by 3, 128 divided by 4, 160 divided by 5. Okay, once we simplify, we get 18, 27, 30, 32, and 36. So if you notice, each one of these are different. They're not the same. So that means no, there is not a proportional relationship. And since there's no relationship, you cannot write an equation for the relationship. Again, you don't have the same constant of proportionality, so that means you do not have a proportional relationship. Okay, let's look at number 3. Try this on your own, pause the video, and we will come back and we will go over it. Okay, so in number 3, 32 ounces of chocolate costs $4.50. Then we have 5 pounds of chocolate costs $11.25. Show that the relationship between pounds of chocolate and the cost is a proportional relationship. Then write an equation for the relationship. Use the equation to determine how much it would cost, and this is another 7.5 pounds of chocolate. Okay, so the first thing that you need to know is that 1 pound is going to equal 16 ounces. So if I have 32 ounces of chocolate, I'm going to divide that by 16. That's going to give me 2 pounds of chocolate. This way we're going to keep everything in pounds. So we'll do cost over pounds, because it's our y over x. We have 450 over 2 pounds. We have 5 pounds of chocolate for $11.25. So we're going to test if there's a proportional relationship. we can find the unit rate of each one. So I'm going to do 450 divided by 2, and I'm going to get 225 per pound. The unit rate for here would be 1125 divided by 5, and you'd also get 225 per pound. So then if you have a constant of proportionality, which is your 225, I am going to write my equation, which is y, the cost, is going to be equal to 225 times x, which is times the number of pounds. And if I want to figure out how much money I'm going to spend for 7.5, I would do y equals 225 times 7.5 pounds. Once I multiply, I'm going to get 16.875. So this would simplify to $16.88 for 7.5 pounds of chocolate. Okay, so make sure you identified your key word. Make sure you write down any questions that you have to ask me later on, and I will see you in the next video. Bye.